Why not search for the chief historian near the gardener and his massive farm? There's plenty of food, so the historians grab something to eat while they search. You're about to settle near a complex arrangement of garden plots when some elves ask if you can lend a hand. They'd like to set up fences around each region of garden plots, but they can't figure out how much fence they need to order or how much it will cost. They hand you a map, your puzzle input, of the garden plots. Each garden plot grows only a single type of plant and is indicated by a single letter on your map. When multiple garden plots are growing the same type of plant and are touching, horizontally or vertically, they form a region. For example, that. This 4x4 arrangement includes garden plots growing 5 different types of plants labeled A, B, C, D, and E, each grouped into their own region. In order to accurately calculate the cost of the fence around a single region, you need to know that region's area and perimeter. The area is the number of plots the region contains. Yep. The perimeter, each garden plot is a square and so has 4 sides. The perimeter is the number of, sides of plots in the region that do not touch another garden plot in the same region. So you're right, plot is a square, regions are not. Okay, so, yep. Plants of the same type can appear in multiple separate regions, and regions can even appear within other regions. The above map contains 5 regions, including some embedded regions. Due to modern business practices, the price of fence required for regions found by multiplying that region's area by its perimeter. Yep. Okay, large example. Great. What's the total price of fencing of all regions on your map? Let's take the large example here. That'll be our example data. Let's take then, and kernel. You're a .NET Interactive kernel. Save you. Okay. And then let's go ahead and get our real puzzle input, which is enormous, as expected. Paste that, do that. It's borderline ASCII art. Okay. Save that. Okay. So there's our values. Now, in utilities, one of the things we want to do here is we definitely know we want to hashbang import. Yeah, Big calling it a garden. Yeah. Import core.ip. Let's just go quickly here to Polyglot notebooks. No, it's .NET Interactive import. There we are. Oh, import magic command. There it is. Import, just path to file. Okay, great. Let's run this and see if it works. Yes, okay. So in theory, I now have those things. So let's go ahead, run all, and then let me just see here. Yes, coord. Let's just check that here. Coord A is 1, 2. Yep, no freakouts. Coord has come in. That's what we wanted. Okay, so now the first thing here is, of course, I didn't bring over the map reparser. So let's go find that. Day 7 used it. I thought day 7. No, day 7. What day had I been reading? Don't save. Day 10, I know we used it. No, day 10 was that day 11 I grabbed there? Yeah, day 10 did use it. I just clicked day 11. Okay, here we go, and grab that down to here. Okay, we don't actually need to turn those into ints, though, so it's just going to be line.toChar array. Okay, so there we are, and let's just see if I do that. Yep, okay, there's my sample data. Let's not leave that in there, but all right. So now, close day 10, scooch this stuff back over here, and take a look back at how we want to be thinking about this. So, all right, what we basically need to do is for every position, we need to generate the region. Each letter is not guaranteed to be a region. So, okay. Thing 1 is we want to find the regions and record them in some way. Thing 2 is then, we're kind of, there's some flood fill action going on here. So, okay. Let's go ahead and just say, probably the easiest way here is let's just say here, class region. A region has a list of coord cells. And let's also just initialize that as we're starting it up there. All right. And a region has, and we can have multiple things with the same plant. This particular one doesn't, but I want to be remembering that it is entirely possible. This has, yeah, four different X regions there. Okay. So what we want to do here, yeah, list coord cells, and then, I mean, honestly, this one I might solve with some OOBS, because this is one where sticking all the things onto regions might just, the on the things might actually be a nice way to do it. I normally don't think in terms of object orientation, but, sometimes it's not a bad way to think. So, okay, a region has a list of cells. And then I think the region also needs to have a read-only car thing map. So, and actually here, let's just say, yeah, public read-only car thing map. And public list coord cells. And what I do want to say here, yeah, this is read-only, but I'd like to make this extremely read-only if I can, but we'll think about that. Oh, neat trick that I'm playing Antimatter Dimensions at the same time as this? Oh, just like this. Antimatter Dimensions is an idle game. It's idling. I play incremental games. I'm actually playing 2 incremental games right now, but yeah. I am straight up 100% playing Antimatter Dimensions at the same time as this. You see? That's a number and it's going up. Okay, so here we go. Public read-only list coord cells. But yeah, I don't generally stream idle games because they're not that exciting to stream. Okay. So the region needs a reference to its map, and it needs to know what cells it has. And I think the other thing I just want to do here is, yeah, public char value. Required char value. Oh, must be settable, right. So, that'll be... All right, I guess that can't be read-only exactly. It'll be, yeah, no, car fank map, get init. Going to actually, this is going to look a lot more like my Godot code, actually. So, yeah, let's say here, yeah, cells equal, so that's a read-only list of cells there, and then a required char value, and again, get init. Okay. So now we've got a thing that can hold the structure of a region. And part of my goal here is I want to know what cells have been visited. So in addition to our, car blank map, what I'm also going to say here is bool. No, actually, no. No, hang on. But let's just start here looking at everything. So for each, huh. Okay, now I've got a fun little way of handling visited here. So let's just go ahead and say set coord, or I'd say hash set to visit equals new hash set, and then for int I equals 0, I less, or do this sensibly, int r equals 0, r less than height, r plus plus, for int c equals 0, c less than width. I think I capitalized them now. Yeah. Or did I? Oh, wait, hang on. Oh no, I just didn't pull them. I pulled them over here. Int height equals map dot length, int width equals map sub 0 dot length. Great. Height, width, c less than width, c plus plus. All right. And what we're just going to do is we're going to say toVisit.add row column. Okay, now we've got a set of all of the existing things here. All right, rerun use of height exists. Rerun use of that exists. Great. And let's just say here now, toVisit. Whoa. Uncollapse you, but how did you get collapsed there? There you are. Okay. There we are. We have 100 there because we have a 10 by 10 grid. I presume it's 10 by 10, but yeah. Yep, it goes up to 0 to 9. Great. So let's strip that, but that means we've now got a set of everything. So now, let's go ahead, new thing. While toVisit dot count is greater than 0, toVisit dot I don't know. We just want to grab. We want to grab some element in it here. Single gonna no single will be only one there. Yeah, right. toVisit.take one. That just takes one element there. Yep. Returns a specified number of contiguous elements from the start of a sequence. Coord seed equals toVisit.take one. Cannot implicitly. Oh, right. That's an enumerable. Dot. Actually, hang on. Can I just take toVisit dot first? Yeah, I can. Okay, great. Now we can just say here, first of all, toVisit dot remove seed. All right. Now, we've just grabbed a random coordinate that we don't that we haven't yet used. So we're going to say here, hang on, list of regions is a new list. Great. Region equals new region, and we need to tell it map equals map. It's going to have some, yeah. Cells equals seed. Which I can't do that. Oh no, hang on. A read-only field. I don't actually need to make that read-only, do I? Actually, yeah, I'm just going to say list coord cells. This will make my life easier. Again, get init. I don't want these things changing out from under me, but we can set them as they start up there. No equals. Okay. Also no semicolon there. Great. Boom. All right, redo that. Yep. So cells equals seed and value equals map sub seed.r seed.c. Okay, there we are. We've constructed a new region and we've given it the data it needs. So now what we just want to do is for each neighbor in cardinal directions dot select. Actually, here, let's just say var neighbors equals we're going to select the cardinal directions. No, right. Add c comma seed. All right. So for you have our neighbor cardinal directions add c dot seed. For each neighbor in neighbors, actually, So hang on. Actually, let's do a little bit smarter here. Enables with cardinal directions. Dot select c add c dot seed. Then we need to do a couple more things. Dot where is inbounds. Where c goes to is, or actually no, where is inbounds, because literally I don't need to wrap something when the thing is already the correct kind of predicate. Okay, where is inbounds dot where to visit dot contains. Can I do that? Yep. Cannot convert from method group to a function that goes from RC. Oh, right. Is inbounds. Yeah. Where C goes to is inbounds of, because is inbounds doesn't know the width and the height. So C, comma. Let's just go ahead here while we have this. Coord size equals width height. Is that how I used the width and the height in the in coord? Yep, width height. Great. Don't save that. Okay. I know it doesn't exist in the current thing, but it will. There you go. Now it exists. Okay. Is inbound C size where to visit dot contains. Okay, so now we're finding all of those things for each neighbor in. Oh, you're right. For each coord neighbor in neighbors. So this is neighbors that are not off the grid that we still need to visit, and dot where C goes to map map sub C dot R map C dot, yeah, C dot row C dot column is equal to, let's go ahead and get our value here. Car value equals there we are. Okay, and where the value matches. So don't leave bounds. Only use things worth planning to get, and if it's the same value, then we're going to say for each coord neighbors in that list, we are going to say to visit dot remove neighbor and region dot add neighbor. Oh, sorry, region dot cells dot add. Because yeah, those things are connected. So this is just a little. So that's going to do it for one step there. But then what we also need to do is this actually has to be a somewhat recursive thing here, because we also then need to say that we need to tag this for here. So what I actually want to do here is void process cell coord cell, because hey, nothing succeeds like recursion. Okay, so now to process a cell, we do this, but now instead of it being, all right, all of those values still get set, but cardinal directions dot select c dot at c and seed, right? Instead of seed, it's going to be cell, and that's really the only change. And then, right, we add that to cells, and then we say process cell neighbor. Okay. So, and actually what I just want to do here is Right, region.cells. Is that a hash set? It's a list. It's not a list anymore, because that way it doesn't matter if we add things multiple times. Will remove be okay if it's already been removed? Well, we'll find out. Okay, then we say process cell seed. And then let's print out regions. Okay. Oh, has to be yeah. Regions end up empty. Oh, hang on. Regenerate a region, but we don't ever add it. Regions.add region. Try that again. Regions are still empty. Okay. Run all. Oh, no, there we go. I just need to run other stuff. Okay, we ended up finding 10 regions. Let's see, is that correct? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11? Oh, no, 0 to 10. There are 11 there. Okay. Right. Their maps are always the same, but value R, value I. Okay, yeah. So that's a nice little quick thing of just, for every cell, you need to do a recursive search outward from it. And as you do that, strip things out of the cells we need to operate on. Great. So now I have these region objects. Okay. So now what we just need to do is, for a region, we need to figure out the price of the region. And right. I believe we count fencing on the exterior as well. There, yeah, the outer edge. Yep. Okay. So what we just need to do here is let's go back to our class region here. Public public area. Oh, hang on. Int area. Our cells dot, it'd be probably count. Yeah. Okay. Public int perimeter. Get. All right. So now what we want to do here is for each coord cell in cells. So the easiest way I can think of to get the perimeter would be, for every cell we've got, the question is, for each direction adjacent to it, is that cell, we add one to the perimeter if that cell is not also a cell in our list. So we're just going to say, yeah, for each coord cell in cells, and we have our code for finding the neighbors there, which does this. We don't even need to care if it's inbound, because we're never going to look at it. So var neighbors equals cardinal directions dot select. Non-static field method or property cardinal directions. I guess because I'm inside of a class, I can't pull that out of reality. Well, that's fine. Static cedars equals. Is that gonna work? Invalid token. Oh, hang on. Static coord array cedars equals cardinal directions. Nope. That's okay. That's a slight annoyance, because I would really like to be able to do that. An object reference is required for that. Okay. Let me see. If I hover over it here, what object does it think it's on? It's a field of some kind of a magic generic object. Damn it. Okay. So yeah, using objects in this environment is a little bit harder than it seems. That's unfortunate. But, okay. The easiest way to do this is going to be, I'm going to go over to coordinate, I'm going to grab that definition of cardinal directions, I'm going to come back over to here, and I'm going to put it right here as a static piece of data on region. Great. Okay. So now we have our neighbors, which are just the cardinal directions, and then if not cells dot contains, oh, right, hang on. Actually, we can do better than that. Cardinal directions dot select. What I just want to do here is you will say, yeah, hash set of coord neighbors equals a new hash set built off of selecting from those cardinal directions. Because that means that the easiest thing to do here is actually, no, I can do easier. For each coord cell, we're going to say no, that's wrong. Okay, yeah, the hash set of neighbors is that, and then we're going to say neighbors dot accept. Let me check. Neighbors dot accept is produces the set difference of two sequences. Yeah, neighbors dot accept cells. Dot count. And then what I just want to do here is we're going to say int result equals 0, result plus equals neighbors except, so count is apparently a method group there. Okay, great. And then return result. So what we're just doing is for each one of those, we're going to look, and for each one, look at how many neighbors it has that aren't also in the set. And it doesn't matter if they leave the board because the neighbors outside the board are still counted. We still have to put up fences on the outside of the board. Okay, so that gives us our area, that gives us our perimeter, and so then for price, public int price is area times perimeter. All right, so now what we just want to do here is, for each var region in regions, we're going to just say here, I wonder if I just display region. I want to see what happens if I do